right, I want to go over a few problems we didn't have time for this morning. If you were in the 8:45 class, then you did this one, so fast forward through this one until you see the next one. If you were in 8 o'clock, what I want you to do is pause it for a few minutes and try it on your own, then unpause it and we'll go through the solution. All right, hopefully you got a chance to try it out. So what we're looking for here is this angle all the way down here. We can see that we have zero information about, I won't say zero, but we don't have any other values for the angles in that triangle. So that's where we just go to somewhere else in the problem. We say, well, what information do we have? We have this 116-degree angle, and from that, I know that's forming a linear pair with this angle here. So right away, I can say those two angles are going to add up to 180. So I can take 180 minus 116, and I get 64. So I know this angle is going to be 64. Now I see that this is an isosceles triangle. I know that I have these two congruent legs here, which makes these two angles the base angles, and I know they have to be the same. So I can fill that one in as 64 also. Now with this triangle, I can see that I have 2 out of 3 angles. And so right away, I can use triangle sum theorem to say 180 minus, we could add those together. We can say 64 plus 64 is 128. And we can say that's going to be 52. So that gives me 52 for this angle here. And now we always want to have our basic angle pairs in mind. So we know our linear pairs. We use that at the start. We know those add to 180. And we also always want to be aware of vertical angles. If we have angles on the opposite side of an intersection, we want to know that those are going to be congruent. Put some little congruence hash marks in there. So if I know this angle is 52 here, I know this angle is 52 here. Now I've breached the other triangle. I know a little bit information about it. So I can say now I have these congruent symbols. So I know those two sides are congruent. I know that makes these two angles the base angles in another isosceles triangle. So I know those are congruent. I can take those 52s and add those together to get 104 and subtract that from 180, and that will give me that last angle that I'm looking for. That'll give me x of 76. Let's try another one. All right, I'm going to go backwards, I think. All right, so if you are in 8 o'clock or 8:45, I hope you're both looking at this one. Go ahead, pause it, and we'll go over the solution. All right, hopefully you paused it. All right, we want to solve for A and B in this little Frankenstein triangle. No values given to us at all, or are they? We've got 3 congruent sides in this triangle, making it an equilateral triangle. I know right away that all 3 angles in an equilateral triangle are going to be 60. That's the only way to get 3 equal measure angles adding up to 180. So A has got to be 60, so I can at least cross these out here. So what's B going to be? We could guess it looks more like a 30 than a 120, but sometimes things are not drawn to scale, so we better confirm that. So there's nothing that really helps us go directly from A to B, but I can look at some other angles in these triangles. So this one here, I can see that once again, I have that linear pair where those two angles are going to add to 180. So I can take 180 minus the 60, and I can get 120 for this angle. And now I can see that I've got an isosceles triangle on the right. All right, hopefully that's not, maybe I don't want it to look like 2 pretzel sticks. Oops. Maybe I'll just replace that blue one with a red one. Now we can see that there's 1 pretzel stick here on each side, so that makes it isosceles. So I know that this angle B down here and this angle over here, they have to be congruent, right? Those are the base angles in an isosceles triangle. So I can take 180 minus that vertex angle of 120, and I get 60. So I know these have to add to 60. And they have to be identical, right? So the only way to get their measure is to take that 60, divide it exactly in half, and we get 30 for each one. So these problems are a little bit of a puzzle. It's a lot of just filling in what you can to start and, just adding more and more clues until you get to the bitter end. All right, let's try another one. I want to do this one. Okay, we didn't do one like this in class where we looked at side lengths with algebra involved. So go ahead and pause it, either class, and we'll come back to it. All right, I hope you paused and had a lot of fun. Okay, in this triangle, what I see given to me is that I have these two base angles that are congruent. So right away, I always want you to think, if I have those congruent base angles, that means I also have congruent legs. Let's look at what it's asking for. It's asking for the length of BC. So we want this length right here. So right away at the start of the problem, I can say, well, BC is equal to 7x minus 6. And if only I had an x value, life would be so easy, right? So let's find an x value. That means we've got to set up an equation. There's got to be some x's in it somewhere. And what is an equation? It's two things that are equal to each other. So I can see that in this context, I have these two lengths that are equal to each other. They look different. They're being expressed differently. But I know those are equal because those two sides are congruent. So I can take one of them, 5x minus 10, and say that has to be equal to 3x plus 4. Now we've got an equation we can solve for x. So we can subtract either of the x terms from both sides. We could subtract 4 from both sides, or we could add 10 to both sides. Any of those ways would be a perfectly correct way to start this equation. I'm going to add 10 to both sides. So I get 5x on the left. I get 3x plus 4 plus 10, so that's plus 14. And I can see my left side is really looking nice. There's only x's, so let's make that the side with all the x's. Remove them from the other side. So now we just have 14 is equal to 2x, and I get an x value of 7. All right, oh, little distractor here. This is an x value. We don't want to click on that. We want to go back to what we're actually looking for, which is the length of BC. And we're just going to plug it in. So 7 times 7 is going to be 49, minus 6 is going to be 43. That's our side length. All right, and there's one more problem. If you were in, let's see, which class is it? I wanted to, one class. If you were in 8 o'clock, you're done now. If you were in 8:45, I want you to watch this one. So go ahead, pause it. If you're in 8 o'clock, bye-bye. If you're in 8:45, pause it and give it a whirl. All right, let's try this out. We are going to solve for x. I have a triangle. I've got two of the angles labeled with some kind of x term, and I've got two sides labeled as congruent. So if we have two congruent sides, we've got an isosceles triangle, and that means we also have congruent base angles. So even though we don't have a constant for this angle R, we don't have like 52 degrees, we have 3x. Whatever we have written there, we just write the same thing on that other base angle. Now we've got information about all three angles, and what we know using the triangle sum theorem is that all three angles, so 3x plus the other 3x plus 9x, has to add up to 180. Now I've got 3 plus 3 more plus 9 more, that's 15x total. It's going to be equal to 180, and it's just a little one-step equation. We just have to divide both sides by 15, and we'll get x is equal to 12. Be careful, you could come across a problem where you're solving for this x value, and then it might ask for, say, the measure of angle R. So we plug it in, we find that angle R is 3 times 12 or 36 degrees. All right, I hope that helps. If you have any more questions on your quiz, what day is it? It's Thursday. I think Mr. Small has office hours tomorrow, and I have a help session tomorrow. And we're going to practice more with these kinds of problems also in class on Friday. Email me with snips if you want to ask questions by email too. All right, bye-bye.